All right, so here we are for the 4-2 notes, the unit circle notes. I am going to teach these rather rapidly through the notes. So if you need to pause the video, rewind it 20 seconds, don't be afraid to do that during it. Because I'm going to go really fast through the geometry stuff of it and through constructing the whole unit circle. Then we'll slow down a little bit for the problems that are more relevant to AP Calc. All right, so let's go ahead and get started here. Before we get to the unit circle, before we go into constructing the unit circle, let me tell you what it's for. The unit circle, the reason you need to know it is for when you take the AP Calc exam, there is a non-calculator section of the exam. So you will be expected to do the cosine of 30 degrees without a calculator. And you'll need to know that the cosine of 30 degrees, well, let's see, that'd be right here, 30 degrees, the long leg, oh, that's square root of 3 over 2. You need to know that. You need to be able to do that in your head. Don't worry, you shouldn't be able to yet. All right, but by the end of this, you need to be able to do cosine of 30 is square root of 3 over 2 in your head. All right, so we will get there. We will get there. So that's where we're going with this. To be able to do perfect trigonometry problems for the AP Calc exam in your head and come up with perfect answers like square root of 3 over 2, exact answers, instead of using a calculator and getting point blah 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 blah. Okay, you can get an exact answer through this. All right, so let's go ahead and get started. Before we get into the pre-calculus, we need to go review a little geometry. So let's review your geometry days, whether it be you had Mrs. Pinion and you had her, or whether you had Mrs. Smith and Mrs. Smith says you got to do, okay, whether you had it, or you might have even had Mrs. Gibson, doing her, cartwheels and everything. So regardless of which one you had, those are my terrible impressions. I mean, you didn't have me because I'd have been like, oh, hey, down here, so too high, right? All right, but anywho, whichever one you had, let's review real quickly. Sorry, I make fun of myself too, I guess. But let's review real quickly how to use those 45, 45, 90, and 30, 60, 90 ratios. All right, so if you remember back, we'll do 30, 60, 90 first. If you remember back in your geometry days, you learned that if you take the short leg on a 30, 60, 90 triangle and you double it, that's the length of the hypotenuse. That's all these ratios are telling me. And if you take the short leg and multiply it by square root of 3, you get the long leg. Again, that's all those ratios are telling you. Well, when you put this problem inside the unit circle, okay, it'll look more like this, okay, in the unit circle. That circle will be way out around here, and there's your center of the circle, okay? Well, if this is called the unit circle, the radius is always going to be 1, which means the short leg in a 30, 60, 90 is always going to be 1/2. Half of the hypotenuse, all right? And that also means the long leg is going to be square root of 3 times the short leg. So I can take 1/2 times square root of 3, and I get square root of 3 over 2. 1/2 times the square root of 3, square root of 3 over 1. Okay, multiply straight across. You get square root of 3 over 2. These numbers you need to have memorized. You need to know in a unit circle, anytime you have a 30, 60, 90 triangle, short leg 1/2, long leg square root of 3 over 2, and then I think it's kind of captain obvious, the hypotenuse is always 1. Okay, that's in the unit circle. That's always going to be the case in a 30, 60, 90. All right, let's review the 45, 45, 90 real quick. All right, so you're going to have same situation as far as there's what it looked like in the unit circle. The hypotenuse is 1. Now on a 45, 45, 90, you get the short legs are the same, and you know that the hypotenuse is square root of 2 times the short leg. All right, so to go back, if I know the hypotenuse or the radius is 1, and I want to go back to the short leg, I got to divide by square root of 2. Now we got to do a little math here. So I got to do 1 divided by the square root of 2. Well, if you remember, you have that standard form in math. I don't know why this is standard form, but standard form in math says you can't have a radical on the bottom. Some professor someday said that. All right, so let's get the radical off the bottom. All you have to do to do that is multiply by square root of 2 over square root of 2. And then you get square root of 2 over, that's multiplying straight across top. The bottom square root of 2 times square root of 2 is square root of 4, which is 2. So there is each leg of a 45, 45, 90 triangle. And you need to know those lengths. Both legs are square root of 2 over 2. And yeah, Captain Obvious, the hypotenuse is 1. You need to have those memorized for the 45, 45, 90. And you need to have these memorized for the 30, 60, 90. You got to have those in there. Because then when you go to the unit circle, it's easy if you have those memorized. So get those in there. So let's jump up to the unit circle. And let's go ahead and just put a few of these in. All right, so if I wanted to do the sine or the cosine or the tangent of 30 degrees, well, all I have to do is, oh, I forgot to mention this, my bad. The unit circle always starts on the positive x-axis and rotates counterclockwise. So you're going to start on the positive x-axis and rotate counterclockwise direction for your angles. So 30 degrees would be, that's why 30 degrees is right there in quadrant 1, because you're just rotating 30 degrees from the positive x-axis in a counterclockwise direction. Sorry, I needed to mention that. All right, so right there is my 30-degree angle. I'm on the unit circle, so that side's 1. So my short leg is 1/2. My long leg is square root of 3 over 2. Right here is my 30-degree angle. I can do the sine, the cosine, the tangent of 30 degrees in no time. All right. So the cosine of 30 degrees would be square root of 3 over 2, adjacent over hypotenuse. Remember the 90-degree angles right there. So I'm going adjacent over hypotenuse. Square root of 3 over 2 over 1 is just square root of 3 over 2. So here's my answer for the cosine of 30 degrees. The sine of 30 degrees is going to be the opposite side over the hypotenuse, so 1/2 over 1. So there's my answer for sine of 30 degrees. And then this one takes some work sometimes. Tangent takes some work sometimes. So I'm going to write the answer for tangent down. Tangent of 30 degrees is going to be opposite, which is 1/2, over adjacent, square root of 3 over 2. I'm going to do this up here. So I'm going to have 1/2 over square root of 3 over 2. The reason this takes a little bit of work, and you might have to write down a tiny bit of work on your AP Calc exam to do this one, is because you got to do fractions over fractions. Don't make fractions hard. I got to take 1/2 and divide it by square root of 3 over 2. Well, to divide by square root of 3 over 2, I multiply by the reciprocal. So I'm going to take 2 over radical 3 and multiply by that. All right, instead of doing dividing by square root of 3 over 2, multiply straight across. Well, my 2's are going to cancel, and I get 1 over radical 3. Can't have a radical on the bottom, so I got to multiply by square root of 3 over 3. Oh, that's a little ugly. There we go. I got to multiply by square root of 3 over 3, and I get square root of 3 on the top over square root of 3 times square root of 3 is square root of 9, which is just 3 on the bottom. All right, so here's my answer for tangent. So this is cosine of 30 equals square root of 3 over 2, always the x value of this coordinate right here. The x value, how far over from the origin. So cosine is always going to be the x value of this coordinate. Sine is always going to be the y value of the coordinate. So sine of 30 equals 1/2. And then tangent is going to be y over x. So tangent of 30 degrees is going to be 1/2 over Square root of 3 over 2, which we just worked out the algebra to it, comes out square root of 3 over 3. That's how you're going to use the unit circle. Okay? So for right now, let's just fill a bunch of this in. Okay? And you could do, I don't even want to fill in the whole unit circle. We're just going to do a little bit. I'm not going to fill in the tangents. I'm going to take that one back off just to save some time in these notes. I showed you how to do it. That's the main thing. But let's go ahead and fill in, because you'll remember this from last year as soon as we start doing this. Let's go ahead and fill in some 30-degree marks. All right? So if I flip this over the y-axis, I can easily fill in 150 degrees right now. Instead of being, there we go, just making my reference triangle for you. It would still be square root of 3 over 2, and it would still be 1/2 for the x value and y value, except one thing. I had to go left instead of right. So this needs to be a negative square root of 3 over 2. So my x value would be negative square root of 3 over 2, and my y value would still be a positive 1/2. So the cosine of 150 degrees is negative square root of 3 over 2. The sine of 150 degrees is 1/2. All right, and then we can go ahead and flip that over the x-axis and get 210, no problem. This time, I'd still have a negative square root of 3 over 2, but I would also have a negative 1/2. So both coordinates would be negative this time, and that makes sense because we're over here in quadrant 3. And we can flip that, or we can, let's go back to the beginning, I guess. Let's flip this 30 degrees down to 330 degrees. So I would still have a positive square root of 3 over 2, and then I would have a negative 1/2 because my y value went down half a unit. All right, so you guys, I'm sure, are starting to remember, oh yeah, I remember flipping this around the unit circle. Okay, it's just playing with negatives and positives in the quadrants. That's all you're doing. All right, let's go ahead and do 45 degrees, and then we'll flip it all over the place. All right, so I'm going to do this one in red so you can see it a little better. So I'm going to make my reference triangle from 45 degrees. Remember, positive x-axis, rotating counterclockwise. Right there would be 45 degrees. Drawing a reference triangle straight down to my x-axis. Right there is my 45, 45, 90 triangle. And don't worry if this gets ugly on this unit circle. Let it get ugly. It's okay. All right, so we just covered all the geometry of it. So the hypotenuse is still 1. This time the legs are square root of 2 over 2 and square root of 2 over 2. Well, my x value, cosine of 45, adjacent over hypotenuse, would be square root of 2 over 2. My y value, opposite over hypotenuse, square root of 2 over 2. And then tangent, we can do it in our head. Tangent of 45 would be opposite of square root of 2 over 2. Adjacent is also square root of 2 over 2. You put something over itself, it's 1. The tangent of 45 degrees is 1, if we wanted to write tangent then. Okay? Again, I'm going to leave those off, but just wanted to show you that's where we're going with it. All right, so we could go ahead and fill in all the 45-degree multiples all the way around here. So flipping that over, 135, I would have a negative x value and a positive y value. So it would be negative square root of 2 over 2, and then square root of 2 over 2, and then I could flip that down here. Go ahead and just run it around. Both of them would be negative when you're in quadrant 3. And then going to quadrant 4 here, I'm going to go back to the original, flip it down. So I would have a positive square root of 2 over 2 for my x value, but my y value would be negative in this quadrant. All right, so there, we just completed all the 45. Whew, one more to go. All right, let's do the 60 degree. Now the 60 degree, I'm going to get one more color involved here. Let's go greens for this one. There's my 60 degree angle and my reference triangle made. Well, this one, it's still a 30, 60, 90 triangle. It's just everything moves. Now my short leg is the adjacent side, and my long leg is the y value. Okay, it's going to be the opposite side. So basically, I'm just going to take the 30 degrees and switch x and y. The 1/2 is my x value. The y value is my square root of 3 over 2. So it's going to be 1/2 is the cosine of 60. Square root of 3 over 2 is the sine of 60. Okay, and then we can flip that all the way around. So quickly flip that over all the axes and get all your x and y values filled in. That's right. So the cosine of 240 degrees would be negative 1/2. The sine of 240 degrees would be negative square root of 3 over 2. And then go ahead and do that for 300. It's going to be 1/2 is the x value and negative square root of 3 over 2 is the y value. All right, and there we got all the 30, 45, and 60 degree angles, all their multiples, all the way to 360 figured out. All we have left to do is 0, 90, 180, and 270. This is going to be easy, though. Right here, I'll switch colors one more time. We'll go purple. Right here, well, I can't make a reference triangle because it'd just be a segment straight over. So you just use your coordinates. We know that length is 1 since it's the unit circle, so this coordinate would be 1, 0. So the cosine of 0 degrees is 1. The sine of 0 degrees is 0. And then if I wanted to do tangent of 0 degrees, I would take y over x, 0 over 1. Tangent of 0 is 0. 0 over 1 is defined. 0 divided by 1 is 0. So tangent of 0 degrees is 0. All right? And now just do that all the way around. So 90 degrees is going to be, oh, can't quite see it here. 90 degrees is going to be 0, 1. So cosine of 90 is 0. Sine of 90 is 1. Now this one, tangent of 90, would be 1 over 0. So tangent would be undefined for the tangent of 90. All right, go ahead and fill them all in then. So we got negative 1, 0, and then 0, negative 1. All right, there, we got the entire unit circle filled in. That's pretty awesome. But here's what we've ignored. Those daggone radians. All right, you're going to have radians come into play. So you got to mess with some radians. Don't worry about it. You'll be fine with it. Let's fill in the radians for each of these. And it's going to be one of those like, oh crap at first, but you will get this down. You will have these radian measures down. All right. Now, if you remember, I told you way back, it was over a month and a half ago, so I doubt if you remember, but I told you you need to know the radians of 30 degrees is pi over 6. If you forgot that, it's okay. All right. You need to get that back in your head though. Let's go through this real quickly. All right. So if you wanted to do 30, whoa, why did that jump up there? Stay down there. There. If you wanted to do 30 degrees and convert it to radians, you'd multiply by pi over 180. All right, and then we would get 30 pi over 180. Well, that reduces. 30 goes into 180. Hey, 6 times. So 30 degrees is pi over 6. You need to know that one. You also need to know that 45 degrees, when you multiply by pi over 180, I'm just proving it to you, I guess. You get 45 pi over 180. Oops, degrees, there we go, pi. And 45 goes into 180. Oh, let's see, 4 times. Hey, pi over 4. All right, so you need to know these. And you also need to know, well, this one you don't have to do any math for. 60 degrees. Well, if 30 degrees is pi over 6, 60 degrees is going to be pi over 3. It's going to be double that. You double pi over 6, you get 2 pi over 6, which simplifies to pi over 3. Okay? And you also need to know that 90 is pi over 2. But you don't have to memorize all these. You'll see it in a second. These are the big two. Those two you have to have down. Because you can take these and just spread them through the whole unit circle, and I'll show you how right now. So let's go ahead and put the radians for all these angles, and we're going to do it in about a minute. All right, here we go. So 30 degrees. I should probably You know what, I'm going to do this for you so you can see it better. I'm going to erase everything I have up here so you can see this a lot clearer, what I'm about to put in. All right, so you can just squeeze it in somewhere in your picture, but it needs to be in there. All right, so 30 degrees, we know, is pi over 6. Let's just run this across the whole unit circle. Let's just count by pi over 6s. So this is 1 pi over 6. 60 degrees would be 2 pi over 6. And then just simplify it in your head. 2 pi over 6, 2 pi over 6, the 2 and the 6 would cancel down to pi over 3. So that's 1 pi over 6, 2 pi over 6, 90 would be 3 pi over 6. I'm just going 30 degrees at a time, and I'm doing 1 pi over 6 at a time. Pi over 6 plus pi over 6, 2 pi over 6. 90 would be 3 pi over 6. 3 pi over 6, well, the 3 and the 6 go into each other, pi over 2. And you can just do this for every 90. So that's 3 pi over 6. 120 would be 4 pi over 6, which reduces to 2 pi over 3. So we're at 4 pi over 6 for 120. So 5 pi over 6. That one doesn't reduce. It's nicer when they don't reduce. And then we got 180 to be 6 pi over 6, which is pi. 210, 7 pi over 6. 240, 8 pi over 6, which reduces to 4 pi over 3. Oops, let's put an 8. 4 pi over 3. And then 270 would be 9 pi over 6, which, 9 pi over 6, 3 pi over 2. And then we're at 10 pi over 6 when we get to 300. 10 pi over 6 reduces to 5 pi over 3. And then that'd be 10 pi over 6, so 330 is 11 pi over 6. And we're done, because then we get back to 0. I guess you could write this. 0 degrees is 0 radians or 2 pi radians. I mean, it'd be 12 pi over 6, which is 2 pi. Okay. I think you already knew 2 pi is all the way around the circle, but all right, it's just a good measure. We'll throw it in there. All right, let's do the 45s. So this one is pi over 4 at 45 degrees. So 90 would be 2 pi over 4, which, hey, reduces to pi over 2. All right, so that's pi over 4, 2 pi over 4. 135 would be 3 pi over 4. 180 would be 4 pi over 4. 225 would be 5 pi over 4. 270 would be 6 pi over 4, which reduces 3 pi over 4, or 3 pi over 2. So we're at 3 pi, pi over 4. 6 pi over 4 reduces to 3 pi over 2. And then 7 pi over 4 is my 315. All right, we have just filled in everything you need to know for the unit circle. We filled in all the cosine answers, which are the x values. We filled in all the sine answers, which are the y values. We could easily create tangent out of that, y over x. And we've put in all the radians for all these. I don't want you to try to memorize your way through this unit circle in all of this. I want you to be able to create the unit circle rather quickly. And at first, you might need to draw it, but later I want you to create it in your head. Just when somebody says 5 pi over 6, I want you to go, that's just 5 30-degree angles, so I'd be at 150. So 150, yeah, I'm right here. Okay? And then you can create that 30, 60, 90 triangle in your head that's at 150 degrees. And you'll know that negative square root of 3 over 2 is the x value and 1/2 is the y value. I want you to be able to create that in your head. We'll get there. Right now, let's do one that's not in your head. And I'm going to go, let's go down here. Let's do it. Let's jump into what you need to be able to do for AP Calc. So let's do like 2 of these examples, and then I'll have you do the other 2 on your own. So let's do cosine of 315 degrees. I'll let you do sine of 60 on your own. So here's what we need to be able to do. I'm going to draw an XY axis, and I need to locate where 315 degrees is before I do anything. Well, 315 degrees is 45 degrees from 360. It's almost all the way around. It would be, I'm going to change the colors for you. It would be right there. And we just said it would be 45 degrees from all the way around. There's your reference triangle that you're going to use. Since I'm in the unit circle here, I'll draw it. Yeah, again. Since I'm in the unit circle, my radius is 1. I'm going to make a reference triangle straight up to the x-axis. I know this side is square root of 2 over 2 because I got a 45, 45, 90. And I know this side is negative square root of 2 over 2 because my y value went down square root of 2 over 2 units. Now I can do anything I want with cosine, sine, or anything else of 315. You just got to make this picture real quick. So the cosine of 315 degrees, cosine is the x value or the adjacent side. There's my answer for the cosine, my perfect answer for the cosine of 315 degrees. And you can check this on your calculator. Put your calculator in degree mode, hit cosine 315, you'll get a weird decimal, and then go ahead and do square root of 2 divided by 2. You should get the same weird decimal. Okay, so you can check these, make sure you're getting them right on your calculator. Okay, for now. Later, we'll totally ditch the calculator and expect you to do it without it completely. All right, so there is my answer for the cosine of 315. All right, let's do the tangent of 7 pi over 6. Now, this is one where you need to go, oh crap, 7 pi over 6 is 30, right? So I have 7 30-degree angles. Oh, that's just 210. Convert it to degrees real quick in your head. So pi over 6 is 30 degrees. 7 30-degree angles is 210. So let's go ahead and draw 210 degrees. So 210 degrees. I'm going, oh, there's 180. And I'm going 30 more past 180. Boom, there's my 210 degrees. It would be 30 degrees past 180. Okay, right there is my 210 degrees. From the positive x-axis, 90, 180, another 30 would give me 210. All right, so I'm going to get that out of the way here. Get out of there, Arch. Oh, go away, Arch. Come on. There we go. All right, and then I'm going to make my reference triangle straight up to the x-axis. I know the hypotenuse is 1. My short leg is 1/2, and my long leg is square root of 3 over 2. Oh, I just made a mistake. You should catch these. I'm down in quadrant 3 for my endpoint. Oh, it's going to be a negative square root of 3 over 2 to make me go left, and it's going to be a negative 1/2 to make me go down. And then just do the tangent of 7 pi over 6. Tangent of an angle is the opposite, or the y value, over the adjacent, the x value. So I got to do a little work for this one. So I'm going to do, I'll write it out, tangent 7 pi over 6. It would be the opposite, the negative 1/2, over the adjacent, my negative square root of 3 over 2. We just did this problem a little bit ago, but it's okay, we'll repeat it. The negatives are going to cancel. To divide by square root of 3 over 2, I'm going to multiply by 2 over radical 3. The 2's cancel, and I get 1 over radical 3, and then I'm going to multiply by square root of 3 on the top and bottom, and I'm going to get, and you show as much work as you need to. If you can do it in your head, that's fine. I'm going to get radical 3 over 3. There's my answer for the tangent of 7 pi over 6. You will, most of you, will be able to get to the point where you can even do this one in your head. That's pretty awesome. That's pretty awesome. You'll get there. You'll get there. All right. I'll let you do the sine of 60 alone. I guess I better cover this one. Let's do cosine of pi over 2. Well, pi over 2 is 90 degrees straight up. Well, this one's like, I can't really draw a reference triangle because I'm just straight up. Right here is my reference triangle. That's not a triangle, it's a segment. Okay? So here's how you handle the ones that are at 90, 180, 270, or 360, or 0. Okay, here's how you handle these ones. You just got to write the coordinate down. The coordinate for 90 degrees would be 0, 1. Oh, cosine's just the x value. All done, 0. Okay, so you just, when you get to the 90, the 180, the 270, or the 360 marks, when you're right on one of the axes, just write down your coordinate and use these definitions up here. Sine is always the y value, cosine is always the x value. You're using those definitions. The x value is always the adjacent side. Cosine is adjacent over hypotenuse, so cosine is always x. You're just using that. Okay? So that gives you everything you need to know about the unit circle, all crammed into one little lesson here. When you come back, we're going to do a worksheet on the unit circle, and it'll look more like these ones, where you're going to create the unit circle every time. Okay? So I kind of abbreviated these notes a little bit. You don't have to go back and fill them all in. We'll probably do this one to start class when I see you next time. So we'll get a little bit more of these notes done then. All right. Well, I'll see you guys in a couple days, and I hope you enjoyed your little break over the weekend there. We'll see you on either Tuesday or Thursday. All right. Take care.